Thank you guys for having me. I really appreciate it. And today I'm going to talk to you guys about attacking and defending at scale at Spotify. Anybody here use Spotify? Woo! All right, great. And what I'm going to talk to you guys today about is kind of my day-to-day. And a lot of these ideas have been cultivated with some of my teammates, and I like to give them a shout-out. A lot of these ideas come from some tough situations where we've had to respond to things quickly and just working together over the years. Who am I? My name is Alex Rad for short. My full name is Alex Radocea, a little harder to pronounce. I'm working as a senior security engineer on the product security team at Spotify. In the past, I've worked at companies like CrowdStrike, focusing on targeted attacks. I've also worked on another product security team at Apple, and I got started in security consulting for Matasano in a small little office on Wall Street, testing dark liquid pools. So a little bit about Spotify. Spotify is definitely web scale, you could say. Over 100 million monthly active users and 40 million subscribers. Another thing that it really changed during my time at Spotify is my perspective on what a lot of data means. Before, some terabytes, like, oh man, how are you going to move that from one machine to another? That's a pain in the butt. But Spotify is also quite open, and if you look at some of the questions on Quora, you can find some excellent answers from VPs in tech, and they'll tell you, in 2015, Spotify was a 150 petabyte company. Is there any petabyte company attending here today? One. What we'll do is kind of a whirlwind tour about some of the different challenges that I face, as well as some of the lessons, some of the pro tips that I've learned along the way, and we really take to heart in my team. A lot of the challenges have to do with speed and flexibility. So Spotify really wants to be a technology leader, and the way you do this oftentimes is being on the forefront of technology, and for that you need both speed and flexibility. And when it comes to security, this can actually be a detractor. Security can sometimes act as the brakes. And what we see is if we are the brakes, people will just work around us because they want to get out, they want to make their stuff work well, and they want to do it quickly. A good example is Mr. Colin Powell. He sent an email to Hillary Clinton in the early 2000s complaining about his security staff at the Department of State. They wouldn't let him have his own cell phone. They wouldn't let him go to the corner store without surveillance. And they basically drove the guy nuts. And he worked around them, and he got his own BlackBerry, and he didn't tell anyone. And that same thing is true working as a security engineer. If you're the guy saying no all the time, people will find ways around it. So what you actually have to do is you have to align yourself with people's goals. And it is possible to do it, but it's not easy. It's a challenge, and you've got to really think carefully. And these are some of the strategies, and not all of them, of course. There are many strategies companies can employ if they want to be fast and they want to be flexible. But these are some of the things out there. One huge one, which I think is now an unstoppable force of nature, is open source. We have the biggest contributor on GitHub right now is Microsoft. I wouldn't say they're ever anti-open source, but they definitely had a different business model 10, 15 years ago. Now you have Linux inside of Windows. Did you guys know about that? Pretty wild stuff. And open source has a lot of advantages. One of them, you can hire employees that are already familiar with your technology stack when you use open source technologies. And the bigger one is you can get collaboration that's global. You can get leading engineers at companies around the world contributing to your technology that you're also using, and you can contribute back. And passionate individuals from all over the world can also contribute. And when it comes to speed, having global collaboration is basically unbeatable, unstoppable, so it's not going away. When it comes to security, though, you have some challenges there. How do you trust the code that you're running? Another one that's critical is DevOps, enabling teams to be lean, efficient, let them ship products, let them have control over how they deploy the code. Well, now you have a whole can of worms when it comes to access control. And there are some easy wins, but there are also some hard challenges that are still unsolved. And I don't think any company around the world has really figured this out yet, how to really do it securely. And if you've seen talks by some of the advanced attackers out there, they will tell you they hunt sysadmins. Well, if you have DevOps, every developer is sort of a sysadmin in a way, at least to what they have access to. Another one is continuous deployment. A lot of products today, they've moved towards this model of development because it allows people to make quicker changes that are less risky, and it actually increases development speed because instead of having a quarterly release cycle or an yearly release cycle, it's continuous, so people can constantly ship, see how customers respond, and really get a nice feedback loop going. It's a lot more manageable. When it comes to security, though, if you're doing continuous deployment, are you also able to do continuous security auditing? Chances are your security team is not going to scale, so there are some problems to solve there as well. How do you stop continuous bugs from being introduced? So there are technological solutions as well as some strategic solutions you can do to deal with this. And another one is people are really building scalable systems. They might not know how big their market will grow, and they might not know how big their employee base will grow. So they're looking at systems that scale up and down. The whole concept of what is the identity of a machine in your network is kind of gone because machines can be ephemeral, especially in cloud environments. And then how do you monitor all these things? Another huge can of worms. And there are some tough problems there. And I really believe that open source is unstoppable and not going to go away. It's much too valuable. And sure, closed source software can have vulnerabilities introduced as well, but with open source, the idea is you want everybody to be able to collaborate. So how do you trust everybody in the world with your stuff? Good example of what can go wrong was something called LeftPad. And LeftPad was a project about a dozen lines of JavaScript, and it would pad a string out with white space. Not particularly exciting or interesting, but it turned out to be a piece of critical infrastructure for a whole bunch of companies that had no idea it was critical infrastructure. There's this company called Kike. They're a mobile messaging app, and the developer who made LeftGate also made a project, put it up on NPM, this JavaScript software distribution platform called Kike. So lawyers from Kike have probably some automated system that looks out for brand infringement, and they sent a scary lawyer to this developer. He got spooked. He took down all of his stuff, including LeftPad, and he broke build systems and websites and clients and servers around the world just by removing this code. And that's a relatively benign example. But just as code can go away and break things, people can try to insert malicious code. Just last month, the FBI prosecuted a guy who broke into kernel.org about 5-6 years ago. Kernel.org is where really Linux is hosted. And this wasn't some state-sponsored attacker or a cyber criminal with millions of dollars of funding. This was just some guy in his basement, basically, breaking into a pretty critical part of the internet. So when it comes to open source technology, we still have to kind of figure out these problems. How do you distribute software securely? Is it enough to just have local mirrors of the code? How do you audit all this code coming in? And then another challenge that I really deal with a lot is with cloud services. And they're immensely valuable as well. And I don't believe they will ever go away because, frankly, the products beat out other options. They're able to do stuff like continuous deployment. They tend to also be scalable. So again, they work with businesses that have customers that grow, employees that grow. They're adaptable. They have all these awesome features. But when it comes to security, there are some shortcomings. A lot of it has to do with how do you get good audit records? How do you get good audit logs about what happens? And part of that is now you don't just need to worry about your own perimeter. You also need to sort of think about the perimeter of the provider as well, because your perimeter is no longer just your servers and your employees' machines. It's also your cloud providers' production servers. How secure are they? Because they're storing your data. And how secure is the culture of that company, and how secure are those employees? These are things you have to think about. I think customers today are already doing this when they buy products. They ask for some proof of verification that they're doing auditing, that they're doing the right things. But still, there's a whole lot of area that comes under shared responsibility between you and your providers. And one of the tough things about shared responsibility is it very quickly dissolves into no responsibility. So stuff falls in between the cracks. And another part of this, too, is that sometimes security can just be an afterthought. For me particularly, I think the biggest challenge I have, though, has to do with how do you audit how you interface with the cloud? How are employees using these cloud services? If there is a breach, did attackers leverage your cloud service to get your data? And that sometimes turns out to be much harder than it should be, I think. The first thing that can go wrong is sometimes the audit records you get can be inaccurate. So they might have no good guarantees about the data, or there might be gotchas and exceptions for things that are not logged, or ways to spoof who actually performs an action. Does anybody here use Google Enterprise, Google for Work? It's things like Gmail, Google Docs, and so on. It's pretty easy to see who does because you can look up the mail server and so on. And one of the troublesome things about that is you got to be really super careful with your admin accounts. You should probably not have more than one super admin for your domain, maybe two. And the reason for that is with those privileges, it's possible to completely make these logs questionable. Their admin SDK provides ways to impersonate other users. So if an attacker breaks into that, it's going to be really hard to tell exactly what they did on your domain. Another one is that logs don't last very long. So at best, you'll have like 180 days of logs from providers, maybe 30 days. But when you look at how breaches happen and how they're discovered, oftentimes it can take 1 year, 2 years. They're not discovered in the first week. That's very rare. So after an attack happens, you want to know what was the damage, what did they take, who were they, what were they after. But with these cloud services, the logs are kind of ephemeral. So you have to really make sure that you're backing them up yourself. Otherwise, they're not going to be useful when there's an incident. And security sometimes is an afterthought. And that's something that is better this year than it was last year, and I think it'll continue to get better. But it's still a journey for cloud services. And here's some lessons and some things that we've found for being more effective on our team. Some of the strategies that we employ. And a lot of this has to do with aligning security with speed and flexibility. The first is trying to make our security monitoring scalable. And this can be quite a challenge for a large company. If you don't have very many servers, 1 or 2, you probably have pretty good awareness about what's happening on those systems. But if you're dealing with thousands of systems, it's a lot harder. It's not possible to check all the system logs for those. So you've got to start being strategic with the data that you collect. And here are some of the strategies that we employ. First of all, we try to make the data that we collect actionable. So take all the information that comes in and try to put as much you can into one event where it makes sense. And that one event should give you enough information about why the event happened, who was doing it, and would give you links to the next events you need to look up. Another one that's really key, if you want to scale, is thinking about how to not collect too much data. So one strategy you can do is try collecting unique activity. A lot of systems will basically have events that are generated programmatically, and they're repetitive, automated, so you'll get kind of the same redundant information day after day. When it comes to security, though, you don't necessarily need all of it. And also constantly work to refine your data. So if you're doing incident response exercise and you find a bunch of data is useless and you don't see how it would be useful, just get rid of it. Don't store it. It's not worth it. And here's an example of collecting actionable information. So here you can see a command that I ran on a server. And right in there you can see the heredity of the process. So you have a call tree. You understand the context. You can see the call tree shows this rsync command ran underneath SSH, so there's a log in there. You've got username, IDs, the full command line, and a link to the session. And you can link out and see all the things that happened in that session there. And you can also see it SSH fingerprint, verify how that user logged in, who they are, and kind of do auditing. And we find this tremendously helpful. And I cannot underscore this enough with the unique events. For some things, you want all of them. For example, login activity, you might want all of that. But if you're trying to monitor what's happening on your systems and get visibility, visibility is great, but it's hard to look at all of that. So you got to look at some other strategies. And I think one of the speakers later today will talk a little bit about machine learning, which is a great strategy. But on the road to there, you can start reducing the data by looking at unique things, because a security intrusion is not a daily occurrence on your servers, probably. And a security intrusion is going to have some kind of anomalous behavior. There's going to be something novel about it, something unique in the environment. And you can take advantage of that. And you can be creative about what makes an event unique. And another strategy that we employ is trying to provide the context for the security alerting to the teams themselves that have more information. A good example is when new employees get onboarded and they're being given access to all these systems. Can the security team really decide if a new name is supposed to have access to certain systems and what level of privilege they should have? Really, they don't know, but who would know would be the hiring manager for that person, because they would understand their roles and responsibilities. So checking that and having a record of that shown to someone should go directly to the person that would be able to take actions if the information was wrong. And that's also very helpful. And another strategy that we employ that's a little bit different for monitoring is how do you deal with all this continuous deployment? And really removing the possibility of bugs where you can. And we work a lot to eliminate attack surface, and we try to get in early. Doing design reviews as early as possible when teams kind of have an idea of what their system will look like, and just talking to them about what that attack surface is. Where would someone actually try to break into the system? Sometimes the answer is there's not really much attack surface, and that's great, but if there is attack surface, how can you reduce it? Looking at things like encryption for protecting data in transit, if it's dealing with a lot of user input for a website, thinking about things like cross-site scripting and so on. Is it possible to whitelist characters? Strategies like that. And if you can't do those things, you can look at other ways to make it harder to break into stuff. Isolate parts of your network from another. Take the most critical assets and keep them away from the things that aren't maintained as well. And also look at technologies like sandboxing. There have been huge strides made in operating systems that weren't available 3-4 years ago when it comes to sandboxing and isolation. Another one is training. The security work that you do can be basically shared across engineering staff. So you can do things like hold training exercises, hold little competitions. You can try to gamify it a little bit. Part of training is also providing people the right tools. Some people might not know that Xcode has an excellent static analyzer, so it could just be showing them a three-button shortcut where they can get some interesting results, and looking at how you get these tooling and these thoughts as part of the development process. Because a lot of engineers actually care about what they're doing. They just might not know how to think about it from a security point of view, and they need some tips. And one of my favorite topics is how do you deal with active attackers? So someone's trying to break in or take something or go after your customers, maybe send them some phishing and things like that. And really the first part of that is you should really understand who they are and what their motives are. As we heard today, there are different aspects of hacking, and a lot of people are more curious. So if the person that's being a nuisance to your company isn't really malicious, if they're just some teenagers sitting in their bedroom, you should consider how you're going to deal with them. And one opportunity you have is actually to reach out to them and say hello. So you can use your judgment here. Some people might be malicious, but if it's just a teenager, they could make a great hire someday. So you could try to be open-minded and reach out to them and just have a conversation. And I guarantee you, if it's some person that's driven by their curiosity, it will make their day to talk to some of your engineers. Another part is be ready to respond quickly. Part of this is preparation. Have mechanisms in place ahead of time for attacks that you can imagine. Have things like kill switches, be ready to turn things off, be ready to turn on enforcement mechanisms. And the last part is play mind games with them. As a company, there are responsibilities to customers as well. Attackers don't have a responsibility to your customers. They have fewer things tying them down, so they're always going to be a little bit quicker to respond. And security is a game of cat and mouse. Your response will get a counter response. You will respond again to that, and you'll get back another counter response. So if you confuse them, if they don't know how you're responding, they can't really counter-react. And some of the things that you can employ there are written up here. One of them is really try to delay your actions. look at what they're trying to get after, and if in that chain their payoff is all the way here, you probably shouldn't block them here. You should try to block them near the very end and just collect information along the way. Another strategy that's quite good is don't just respond with no, don't just block. Try to respond a little bit randomly. Try to respond in a confusing manner. And you don't have to just do like a random Gaussian curve. You can be very creative. You can pick out identifiers like IP addresses or device IDs, and you can key those to get kind of square wave patterns where on one day it will work on one machine from one country, and on the next day it will stop working there, but it will work for their friend halfway around the world. And they'll be trying to debug it, twiddling different bits, and they'll get frustrated and maybe give up. And a really good example of that is if you consider having a web store or a storefront. There are firms out there that will go and crawl web pages to try to get pricing information. And your engineers are identifying these crawlers coming in, and it's very clear to them, okay, they're coming from these net ranges, and they have these user agents, and they're fetching these pages in a certain way, and they're crawling our pages because they want to take our prices, and they want to sell them to our competitors who can undercut us. So how do you respond to this? The first instinct might be, okay, just go and block that user agent. But is that what you do? No. Instead, what you do is you respond with misinformation. What you do is you try to pollute that information that they're going after. You pollute those prices. And instead of just returning no information, you return a lower price or a higher price, and you randomize it. And this makes their data unreliable and unsellable, and they'll lose their motivation to do it because now their job will become to figure out if your prices are accurate or not. And they can't really do that because that was the whole point of crawling your service. And another thing I'd like to call out is we have a bug bounty program, and we've gotten some really great bug reports here. Sometimes it's a little frustrating because it feels like we're just educating people looking for a quick buck. But in between all of the less exciting stuff, we've had some really interesting reports where we've learned about things we had no idea about, where we've had exposure that we probably wouldn't have had discovered at all. And we're very thankful to our bug bounty reporters that they report to us rather than someone more malicious taking advantage of it. And we give prizes up to a couple of $1,000s out, and you can check us out on BugCrowd. Thank you.
Thank you, Alex. Thank you. Please have a seat.